Awakening Conference. I would like to introduce the authorities who join us. Dr. Tamara Kolangi, Director of Education at Elan. Dr. Tania Libertad Jacobo Estrada, IPN Research Director. Dr. Emil Alon, CEO of Resonate. Mauricio Gascon, on behalf of Dr. Francisco Iram, Director of Computer Research Center of IPN. Now, Dr. Jacobo is going to share her message with us. Please.
Welcome, everyone. Good morning. And I would like to thank you for inviting me, for having me here. I'm very excited to be here. And I'm here on behalf of Dr. Laura Arreola Mendoza, who's the Secretary of Research and Postgraduate Studies. She couldn't be here due to a prior commitment, but she sends her best and warmest regards to all of you. And of course, to all the people who is following us on YouTube. I would like to welcome the community that is here with us today to listen to this important conference, and that is held within the framework of collaboration between the IBN in Mexico. I want to thank also the International Relations Office, of course, the Center of Research, and Dr. Tamara Kolangi, Director of Education of Ilan, for making this possible. And of course, Dr. Emil Alon, who is a serial entrepreneur, chairman, and founder of multiple tech companies in the US and Israel in the field of artificial intelligence-based search engines and machine vision, focused on groundbreaking technological innovation that can scale, developing vision that can potentially reshape next generation of software and hardware platforms. He enjoys the challenge of moving from vision to product, from product to the go-to-market, and forming the optimal business models. So thank you, Dr. Emil, for being here, for your time, and for this conference that you're going to give us. Thank you all.
Thank you very much, Dr. Jacobo. Before the conference, Dr. Tamara would like to share with us a video about Ilan.
Con la innovación en Israel para mejorar la vida de las personas. El mindset de Israel acerca del ecosistema de innovación es una colaboración conjunta entre gobierno, academia y empresa, y lo que nosotros queremos enseñar a través de la Fundación Ilan es reconocer a los innovadores mexicanos, premiarlos y entonces llevarlos en una delegación a Israel para que ellos puedan entender cómo funciona el mindset de allá, que obviamente ustedes saben es una startup nation, y después venir a México y poder implementarlo en sus empresas, en la gente, en la sociedad, y así poder construir un futuro mejor. Tenemos un video que les va a demostrar exactamente a qué nos dedicamos, y bueno, después le daremos la palabra al doctor Alon para que nos pueda compartir sus experiencias.
Hola, ¿qué tal? Sorry? They took it because they connected to the...
Imaginación, liderazgo, amistad, nobleza. ILAN, Israel Latin American Network. En ILAN impulsamos la innovación, vinculados con Israel, para mejorar la vida de las personas. Israel es uno de los países con mayor capacidad de innovación en el mundo. Lo que esta nación de Medio Oriente ha logrado ha sido gracias a su cultura y a una fuente de motivación para desarrollar innovación, y que podemos describir como el
AR and VR type of technologies. So my previous company was acquired by Facebook in 2016. We have developed a 3D miniature camera that understanding the depth, okay, of the surrounding and reconstructing human skeleton and human movement in real time in a very high resolution. So Oculus, via Facebook, acquired a company in order to have a very natural gesture recognition and ability to operate within the VR without gloves or joysticks, just using your mere hands, bare hands. So you can grab things, throw things, and so forth. So this was my first actual tap into the VR. And as you know, a lot of things have changed. Now we are talking about the metaverse, but specifically my focus and our company focus, Resonai, is on the augmented reality part of things. So who knows what is augmented reality? Exactly. So the idea behind augmented reality is not only object, but is a way to layer what we call physical reality with digital objects or functions or interactions, okay, applications. So basically integrate those capabilities into the physical world. So you know that today there is this very distinct separation between what we call physical reality and what we call digital reality. Digital reality can be tapped in or browsed via those type of devices, mobile phone, computers, laptops. But our bodies and most of our time were within physical realities. So this distinct separation creates limitation in terms of disassociation between space, physical space, and the actual intention that I want to deploy. For example, if I'm in a shopping center and I see an object, I want to know maybe the price. I want to know maybe its ecological footprint, where it was produced, or some other qualities, reviews. And those information, those layers, are disconnected from the physical object. So in order to acquire this knowledge, I need to somehow get my phone, take a picture, write a query, okay, and try to gather the information that is important for me to take an action regarding this object. Okay? So this important information, we don't have interface to it, a natural interface, okay, when our attention is to acquire or to understand this object. Same goes to the physical reality. For example, we invested, I think, something like 25 minutes now trying to hook the computer, the sound, the projector into each other. And the reason is I don't have a direct access. I don't have a unified interface, simple one, to deploy my intention. The intention is very simple. I want to project my presentation, for example, okay, via this device. That's it. When I came here, I don't know anything about this device. I just know that this device should project my presentation. But I don't have a direct interface to say, okay, projector, hello, my name is Emil, please project my presentation. But we can do that. And I will show you today how we can do that, how we can create this protocol, this interface between us and everything within reality in a way that everything, every object, every device becomes a portal that we can easily tap in, integrate, and deploy our intention in a very, very immersive and simple manner. So this is what we refer as augmented reality. And another way to look at it is we are basically now indexing the world. So for example, if we take all the text that Google indexed or others in the last 20 years, so those texts that were indexed, crawled and indexed, now they are approachable via the digital devices, via the queries or search engine. I can reach every letter, every word, every paragraph via those devices because they were indexed and mapped into the digital ecosystem. So they were digitized. So our goal is to digitize the physical world. And we are starting by those big facilities that we as humans hanging around mostly. So airports, hospitals, shopping centers, education centers, universities, residential, mixed living, all these co-working, all this type of real estate hosting us to perform the intention, the action we need as physical entities. Okay? So we are starting by mapping those facilities and indexing them in a way that now we can integrate applications, okay, in a very precise manner. So every phone and later on every smart glasses can deploy the simple intention. So in the case that I came here now, and let's say this facility already is Vera enabled, Vera is the name of the operating system, I will come here and you will authorize me by my phone that I am allowing or I'm allowed to interact with devices. So I will point my mobile phone to the projector. It will give me its interface, its code, everything in order to interact with it. And I can deploy a simple interaction via this interface. So I will have now a direct ability to interact with those devices and perform my intention, okay, based on your authorization that I'm authorized to interact in this space. Okay? So what is the type of interface? Today is the camera. So I just need to point my camera. Once I'm pointing my camera, I will see the layer, the digital layer of data associated to this device or to that device. Okay, so the camera is the mode to sort of direct my attention or to say where is my intention. Okay, I'm using the camera. Later on, years to come, we'll use smart glasses. So did you hear so far about smart glasses? Smart glasses is one of the biggest endeavor that most of the big companies that you are familiar with are taking in order to change the paradigm of the new computational platform, the new hardware platform. So you know that we have shifted from, let's say, mainframes into personal computers, into laptops, and eventually the dominant hardware platform today is the mobile phone. In your hand is the access to the web, okay, via this device. Probably the next hardware platform will be smart glasses. And there are huge advantages to smart glasses as opposed to mobile phone. Because smart glasses, when I'm wearing them, two things. One, we can project photons directly to your retina that completely fool your brain. Or even if they don't fool your brain, there are the digital layers that are injected directly to your retina. Okay? So you're still in space, in the physical space, but there is the level of transparency to the digital information that you can deploy and act upon based on a very simple and natural interaction. For example, if I'm looking on something, let's say this projector again, and I'm staying for 2 seconds, let's say this will be the protocol, then immediately the menu or the interface of this projector will pop up to me and I can deploy and click and do whatever I want. So it's a very natural way. Second, I don't have to do anything in order to see the digital information that is embedded or layered in this space. Okay, so now, instead of just thinking, okay, this is reality, now when I'm putting this one, there's a new set of new type of application and realities existing in this space that I can simply see. Okay, because it's projected based on the location and my gaze directly to my retina. Okay, so this is a very big advantage. It's a seamless way to project information based on the intention of the owner or the person that is operating this space. Okay, much more natural. So I don't have to pull something and think, oh, I need interact with something. It simply suggests itself to me. Okay, and if I want to deploy an interaction, I just have to focus my gaze or my look for, let's say, a certain amount of time to get the relevant interface. So this is one. Right now, we are still, not only us, but everybody, struggling to reduce the technology to the form factor and to the size of a regular, let's say, glasses. Okay, the devices are still a bit bulkier. Field of view of the projected field, digital field, is still rather small, but it will happen, and it will happen pretty soon, that we'll have these glasses. And then mere definition of what reality is will be challenged. Okay, there's a question: what is reality? So now there will be a significant difference between this type of reality and this type of reality. Okay. Next progression for smart glasses will be contact lenses that already are under development. Okay, so it will be more difficult to simply take them out. And eventually, already started, brain-machine interface. So it's the ability to interact directly with the brain in order to evoke or to present layers of information. And this is something that is very important to realize. Our brain is already a VR device. Our brain is already an augmented reality device. Because if you ask a physicist what reality is, what is actually out there, he will tell you nothing is out there. There is no out. Okay? So once you're trying to understand through physics, for example, what is absolute reality, our current conclusion is a potential field. It's a quantum potential field. So the state of reality is not defined only after a certain kind of measurement or interaction. It collapses into what we call an objective reality, or a defined, observable, and so forth. This is the foundation of quantum physics. Somehow, in a miraculous way, our consciousness creates this collapse function. So all what we consider as reality, let's say our separation, the fact that you think you are different or separated than me, the fact that you are thinking that there's space that interferes between us, the sense of time, the sense of memory, it's all generated right now in your brain. So you have an amazing virtual reality device that can take, let's say, potential field, if you use these terms, and transform them into meanings, people, feelings, coherency, reality, material reality, but it's a construct of your brain. So if we had a technology to tap directly to your brain, we can generate totally new set of experiences, yes? Instead of evoking the retina, I can stimulate directly those networks responsible for, example, if you were to go to the beach right now, what will be the sensations? What you will see. So this happens in your brain. So I can shortcut the visual area and go directly to this data transfer associated with that stimulus, specific stimulus, and you will feel exactly as if you were there. Is that point is understood? So right now, we don't know how to evoke in such direct manner and control those experiences. Okay? But we can already, for example, capture dreams. If you go to YouTube, you'll see how, by mapping the V1 area, the first visual perception area that was, let's say, pretty much mapped into some of its properties, we can use this mapping, okay, of the neuronal activity once there's certain stimulus regarding color, frequency, what we call, okay, and then generate back your dreams into the colors, into the shapes, and you can see in YouTube's captured dream using fMRI or other imaging devices that can probe your visual area while you're dreaming. So there's a lot of endeavors now to interact with the brain in higher resolution, more accurate resolution. And it's not just by mapping your current brain activity or networks, neural networks that associated with certain activities that are already mapped, like motor cortex or visual cortex. But don't forget, brain has an amazing quality of plasticity. So you can actually impose or change some of the pathways in order to perform a certain task. So for example, let's say my home has an IoT devices connected to opening doors or to switch off and on lights and so forth. And I want to just think about it. I don't want to click on anything, even not use the smart glasses, point out and reflect my intention via some kind of interface. I just want to think that the door will open and it will open. I want to think to switch on the light, it will switch on. Is it science fiction? It's already operational. There are people already interacting with external devices using their thoughts. So initially, yeah, you're using some kind of electrodes. Usually it's handicapped people. You're implanting certain electrodes in certain places that you know how to evoke them via a specific kind of thought. Let's say there's a certain area in my brain that once I'm thinking about the color red is activated. So the only thing I need to do now is to put an electrode, and once I'm thinking red, it sends a signal to the specific IoT that is connected to this area, and when I'm thinking red, light is switched on. This is how I close the loop. But the beauty here, that the brains now will learn. Next time, I don't even need to think red. After several times, the brain will understand my intention before it's translated even into the word red. I don't have to explicitly or consciously think about red. I will just want this thing to happen, and it will happen. Same goes like if I want to pick the bottle, I'm not actively thinking. I'm not using thoughts as a medium to direct my hand, left, okay, grab. No, I'm not using it. There's a direct interface between the visual perception and the motor capabilities in order to grab this in a very accurate, smooth, and unconscious manner. You know, we can drive unconsciously. We can do so many activities unconsciously because the brain learned already how to operate it without our conscious effort. It doesn't need this proxy. So this is the amazing neuroplasticity of the brain, and it gives us another canvas of possibilities or potential to interact between our brain and what we call external world. But right now we understand there isn't such a thing as external. It's simulated by our brains as external. Even our brains are not within our brains, if you understand why. It's because space is a construct of the brain. So everything I experience, including the fact I have a body, or all the words I'm saying regarding what I understand about my brain, they are part of this specific type of simulation, okay, and interaction of consciousness with this potential. So this is where we are heading. If I need to sort of extrapolate, technology becomes more and more intimate in the sense it's pierces through layers of subjectivity and personality and start interacting directly via our intention to and deploy the actions into the world. And now more interesting things can happen because now I can think about connecting our brains together directly. So what is cloud services basically? Okay. Many computers that are very efficiently in how they interact between them to transfer or to execute a certain algorithms or certain processes. Our brain works the same. Yes. By the analogy, you know that in the 18th century they were sure that the brain works with wheels, and then they were sure the brain was hydraulic, and then they thought, maybe it works electric. Yeah, electric, and then more like electronics. And today the analogy, we think more of computer networks and how computers are working, and we see the analogy with how neurons interacting with each other via the synapses and their networks. So, as those networks, those neurons interacting within my brain, once I have this interface outward, I can have the connection between other people using those networks without even being consciously aware that our brains are now operating together. Okay? So we can synergize intelligence via a new mode of interaction. Today, when we want to leverage, it seems to be, when we want to leverage our interaction, we are talking to each other, we're trying to explaining, we're trying to figure out something together, and then we can do something together and synergize. Okay? But if there's a possibility to directly synergize our brain and our intelligence, even without the proxy of words or meaning, we probably can get much more efficiency, hence much more intelligence. So after I will show you some of the technology and how it's deployed in spaces, several spaces, I will explain a bit some of the technological challenges in order to perform what you're going to see. Okay? We'll go even deeper to this notion of shared reality or where we are heading in that sense. Okay? So this is an example of how the technology, how we are basically digitizing physical space. You'll see the stages of onboarding a space into a digital platform, into the operating system, how the system is basically index and understand the semantics, the objects within the facility. And then the interesting part is the application layer, how you can integrate application within space that everybody with a mobile phone, just by pointing the mobile phone to the desired object or space, they automatically get interaction that are deployed in that specific space. So it's called 6-DoF tracking system, because you know exactly where the mobile phone is pointing out. For example, if I want to now point my mobile phone to this projector, yes, I'm doing like this. Now, if I'm changing the position, it's not a projector anymore, yes? So even a slight movement, angular movement, totally change the intention or where is the vector I'm pointing at. So it has to be very accurate in the sense that every slight movement, I need to detect and understand exactly where the user is looking at via his camera to present the right type of information that is overlaid in that specific area. Okay? So this is called SLAM or 6-DoF tracking system. So let's see how it looks. So this is the digitization process when the actual 3D model is being reconstructed. Second phase is the semantics, so realizing all the objects, all the geometries. For example, you see this board or galleries, doors, curvatures. So basically you create the model, the 3D model of the interior. Now the owner just need to drag and drop. This is his command center. For example, he can now deploy 3D objects within space. Simply pick the object. In this case, it's a very beautiful 3-dimensional shoes. And when the user will point out his mobile phone to that specific area, this is what we will see. So this is how the person looking at this space now will see. So C is now, for example, directing your mobile phone to a certain gallery. You see here there's some kind of offer. Here, when you point your mobile phone, you'll see the next train and all the relevant information. Here it's an invitation to enter this macaroon shop. Here you can see the deployed menu, digital menu, and you can also reserve a place from remote, from 20 meters. You just point your mobile phone, you get the gallery site and interact. Other aspect is, of course, things connected to sensors, real-time data stream. For example, inquire your surrounding in terms of CO2 emission, in terms of oxygenation level, energy footprint. So you can simply take your phone, point it to the space, and see all those matrices extracted from the sensors. Okay, so you can see how operators efficiently can redesign their space using this type of technology. Let's see some other examples in the level of applications. So this was the general onboarding process and some of the applications that are relevant within shopping experiences, mall centers, and so forth. Let's see some other experience just to enhance your understanding regarding the technological challenges associated. So here, I will show you a game, a multiplayer game that was developed on top of our platform. Now, one thing to remember, this facility wasn't there 2 days before the conference. It's the CES conference, the Consumer Electronics Show. It's the biggest conference, the biggest technology conference in the world, held in Vegas every year. And all the booths, everything is built there a few days just before the show. But the application was created before. So the application was created based on semantic data. Sorry? Something is played. Sorry. So the application was designed based on semantics, not based on geometry. Okay, so let's see how I design now in your brain. I will design an application based on semantics. So I will ask you to close your eyes. Each and one of you, please cooperate with me. Close your eyes. Don't be afraid. I will do nothing. Relax, relax. Take it as an opportunity to rest a bit. Now I want you to imagine that you are entering into your house through the main door. You are walking directly to the living room. And now you are sitting on your most comfortable, usual place. Suddenly, you remember something, you are standing up, and you are strolling to the kitchen, directly to the refrigerator. You open up the refrigerator door, and you pick up a beverage or water. Now you are walking with this beverage back to the living room, to the exact same position you were sitting before. You're sitting down. That's it. Please open your eyes. Who could actually visualize this experience? Don't be shy. We're doing something together, so cooperate. Yes. You can, the people who say, yes, I could actually visualize this, visualize. Did ever I was a visitor in your home? No. But I just generated an augmented reality application in your home. Why? Because I used a common tokens, words, semantics to guide you, okay? And you sort of completed the rest of the details to generate a very convincing simulation. So this is how our SDK is working. The developer is developing the application based on semantics. For example, the avatar is walking in the corridor. Then something is coming from the wall, you will see. Okay? And once there's a structure, the engine is matching the semantics to the existing defined semantics of the structure. And this match is actually locking the application and the registration of the digital behavior to the physical behavior. I hope you understood something. Let's see it. So this is a multiplayer game during the conference. So you use your mobile phone. You see here a screen capture of the mobile phone of one of the players. So he's asked to navigate after this blue arrow. So he's walking. And then he's directed by the voice. And something is popping out of the real wall that is there. Now you're asked to walk after this ferry. And there are other players, they see it from their angle, of course. It's the same state, same scenery, like in reality. Now see what happens. See the level of accuracy of the behavior of the digital object and the physical wall. Okay, although camera is moving, people are moving, there's a lot of changing transient data, but you see how realistic is the behavior of the digital object through the moving camera in real time. Now those blocks are falling, you need to avoid them. And all the players now playing this game, they are in a quest to save the ferry out of the hands of this ogre that snatched her. So I'll move a bit forward. So in the way, there are many other challenges. You need to confront, like those creatures. The ogre now is very angry, so he starts banging the wall with his fist. See again the level of accuracy of the interaction between the digital and the physical. He tried to put these boulders on your heads to kill you, but you need to avoid. And eventually you are succeeding, you are moving to the next level, and then there's the final quest. And this is a great example of the level of accuracy. All the players now are focused on the final stage of this quest, and see what happens. This is our real signs, you can see there. And now this is what you see through your mobile phone. This dragon. See how realistic his behavior within space. His behavior within space. This is another player. You can see his avatar on his shoulder. And everybody now is focused on try and kill this creature to save the ferry. The mission eventually was successful. So this is another example. The reason I'm showing you this example, so for you to understand the challenges, the technological challenges, because you want to build a scalable platform for content creation. So once I created the content, I can deploy it in many other sites without really understanding the geometry, topology, or the specifics of these sites. This is what you can gain. This is how you can gain scalability. So important. Otherwise, there's no business model. It will be too costly to develop an application to a very specific area. You cannot scale. Second challenge is the registration. How you register such accurately that it completely looks natural, okay, between the digital object and the physical static object, even though we know the camera is moving or the head of the person will move. So you need to a real-time rendering that will be very, very, very accurate. This is the second challenge we solved. Okay? So all this, in order to have this type of experience for the mobile phone holder, and later on think how amazingly it will be for one with the smart glasses. Okay, and now we can actually dock, behave, and see all these beautiful creative aspects of the digital content creation possibilities embedded and naturally behave within space. Okay, so I can see, for example, your favorite actor or cartoon figure just entering this hall, walking, say, hey, hello, how are you? Sits very naturally in a chair. And I'll see it as if I see you. The level of accuracy of the photons transmitted into the smart glasses is so amazingly accurate that it completely fools the brain. There was a company called Magic Leap, still is. One of the founders of Google, Sergey Brin, he entered their offices. They gave him, it wasn't like this, more bulky, but something on his eyes. And he say, okay, you are in this room, yes? Yes. In this room, you see there's so many objects. Some of them are totally digital. Amazing capability, you want to invest in such company. Okay? And don't worry about Sergey Brin. He has much more than $500 million. He invested eventually. Yes, because the photons that were projected, which actually imitate the phase of a photon that comes from the same position in a very accurate manner, to completely fool the brain, because our molecules, okay, the rhodopsin molecules that are changing their configuration once a photon hits them and then create a signal, electric signal to the brain, they have frequency that we call color, and they have a phase. From the phase, we deduce the distance they traveled. Okay? So once we are transmitting photons with the same phase and the same frequency, our brain cannot differ whether it came from reality or from some kind of waveguide that was projected to the retina. So this is what technology is already achieving today. So very soon to be, will be in a reality, very convincing reality, but has all the playfulness, all the capabilities of the digital creation implemented into those physical spaces. But we already argue, we are already in that state. I'm virtual. Your brain constructs me. in the specific way you construct. Only for you. You see me only in the way you can see me. So this is the thing in the first place. It's not something different, but we have now an ability to look at it and understand much more about ourselves and our perception. And this is how I see technology. Technology is a mirror, another mirror reflecting on who we are. It's not something external to us. Some people, they say, oh, it's not natural. Everything is natural. Consciousness is natural. It's a product of nature. Consciousness is a product of reality. So everything that is derived out of consciousness, every invention, is part of nature. And of course, as is nature, we have destructive forces, and some, very good forces like winds can be destructive, or very good forces like waves can be destructive in certain cases. Same goes to technology. It goes together. If the technology is so powerful that it creates such a benefit, for example, they take these small micro robots, nanorobots that can now stream into your vessels and constantly clean your bloodstream or your internal organs. Of course, they can kill you. They are within you. So if there's a malware or virus in those nanorobots, oops, sorry, we had a problem. We need to do a recall. Recall of what? Of you? So yes, amazing technology that can help you a lot. No argument there. But in the same manner, with the same correlation exactly, it can damage and create a huge damage. So it's our responsibility to see how we can reduce the probability of misuse of technology and direct the technology to the benefit and to development, to the evolution of our species as human beings. So if you take the case of artificial intelligence in general, for me, it's a beautiful thing because, again, it's externalizing certain aspects or capabilities we have. So it's externalized, so we can focus ourselves on the internal assets that can still or aren't still externalized. I will explain. If, as humans, we are identified with the capability to think or to solve problems, this is our ego as humans. Oh, yes, we're different than any other creature because we can simulate, we can solve very difficult, complex, holistic, multidimensional problems. And let's say now we'll have computers, maybe quantum computers, maybe not quantum, classical computers, that can do it better than us in many cases. It's a great thing because this ego now is taken out. And we can go beyond and ask ourselves, so who we are as human beings. If computers are now more educated than us, like the case of Watson that beat this in the game of trivia. If they can tap into knowledge faster than us, of course, memorizing infinitely better, now can solve more complex and more multidimensional problems, and now even so creative in creating images. I don't know if you saw these latest engines that creating images from text. I can write text, for example, car flying in a purple sky in lucid dream. Boom! There will be amazing image instantly generated by the AI software. No artist can compete. So if this is taken from us, it means we cannot identify in the level of ego, in the level of what differentiates us anymore on those aspects. So we are pushed to redefine what it means to be a human being. And this is a beautiful thing because we have to go deeper to layer of emotions, to layer of consciousness, and even beyond that. So the good news, we are already there. We are not recognize it. We are not conscious to it because we are slave of our communication platform, of how we call phenomenon and how we observe phenomenon. But our brains, our consciousness, not even brain, because brain is another product of how we understand and process or perceive things. But our consciousness is much vaster than that. But we are so enslaved in the way we are perceiving world because we are branded with this phenomenon, with this cause and effect, with these tokens, with these words describing reality, that we're simply not aware that a higher dimension of consciousness that existing right now within us. So once this is altered and changed, we have a chance to go to the next level in terms of our consciousness evolution. That is nothing but to understand better who we are, and hence who all of us are. So this is, for me, the role of technology. This is why I'm never afraid of any technological evolution. Because when the knife was invented, it could cut through leather, it could cut through fruits or vegetables, and it can cut through human flesh to kill somebody. So it's not the knife that is dangerous or beneficial. It's the intention of the one who holds the knife. So the best way we can do is to purify our own intention. It's the best thing we can do. Once we at that position, everything is changed anyhow because we see the world differently. So this is sort of extrapolating on the current hardware and software platform that we are developing and where we are heading in terms of AI, in terms of VR, in terms of AR. And why, for me, and this is the main reason I'm having this talk with you today, it's a very optimistic and positive development to enable us understand something bigger than we are figuring right now. Thank you very much. And now, thank you. And now I would love to answer any question you may have, whether it's technological one or other. Yes, please. Yeah, of course. Yes, so in health, if you think about VR, for example, or AR, let's say you are equipped with these smart glasses, okay, and look on the body of a person, whether, let's say, operation. Now you can have a lot of layers that are, by the AI, are detected or streamed by the scanning devices for you to make decisions or for the robot that is operating to make decisions. So you have another visual cortex, okay, to assess situation, to be very accurate in the way he analyzes the visual scene in front of him in order to take the right type of decision that will be more accurate and more robust in that case. So probably robotics operations will be one of those immediate facts. And the other one is education. Once you have these tools, you can think about how it's more easy to educate students and doctors and anyone dealing with medical services using VR, using AR. So basically one of our verticals, it's healthcare systems, hospitals. So even navigating within campuses, you don't believe how many people in big campuses, big hospitals, they are losing their way. They need to go to a certain appointment, but they don't know which building, which campus sometimes, and definitely within the building. So if you have now a navigation tool based on your camera, and you simply say, I don't know, EG, room number that, campus number that, and then you have a camera to guide you through, you have an amazing way to navigate yourself. Or think about doctors or anyone that using those devices, simply using the camera to understand and to operate the device from remote instead of touching it, so less infections, or getting tutorials embedded via the AR. Okay, so of course, in the level of facility management, huge applications. So numerous applications for healthcare, whether hardcore or in the peripheral. More questions? Yes. Mhm.
Um, well, I worked in property operations here to Cancun for 2 years. And before defending my thesis, I had the opportunity to present my research in the Latinx workshop in CVPR. So there I met some people that is doing um, like digital twin for a small refinery, well, for a sectional refinery. He was telling us that their goal was to be able to detect the way people was doing maintenance and also detecting intruders or people not authorized. So I don't know if what you have shown us today is more focused to the consumers.
So let me show you an application that is focused on facility management. Okay. This is a company called Comscope. It's a cable and IT company. Ah, it was closed. So here you can see a technician and how he operates and interacts with a space in terms of facility management. So when he points his mobile phone to a specific hatch, he can see all the connectivity grid, all the functions, and all the tasks that are associated with this specific thing. Now he's getting mixed reality-based navigation to his next task. So he's navigating through the facility. So these arrows, they are digitally implemented there, of course, for the mixed reality. Those arrows. Okay, so now he's reaching his destination. It was a server rack. And you see this digital panel that gives him the name. When he click on it, he gets the tasks he needs to operate. Okay, so he's fulfilling the task. And now he's navigating to his next stop. When he points his mobile phone to his next stop, you see it's a Wi-Fi connector or a modem. Again, the tasks that are oriented to that specific place and all the connectivity grid of all the elements that are connected via the path. Now we can also add information. So you have a read-write way. So you can add information for these devices, okay, for the next technician. For example, in this case, he's pointing here. You can see tag. He opens the device. You see all the data associated with that specific device. So everything he's pointing out now is adding new device. So from a list of objects, you can name this device, save it, and next technician will get all this information. So this is one example. Let's see another example. This is very similar to the case that we indicated before when a person enters, for example, into a conference room. And let's say he's authorized, okay? So he has all the access control because he's authorized to do that. So when he enters, he can see all the devices that he can interact with just by hovering his mobile phone. So when he looks on this area, he can get, for example, the climate controller. Here is the conference controller, and he operates everything from his mobile phone because he's grabbing the interface. So he can switch on and off the air condition, chilling system, heating system, or lights, or projectors, everything that is applicable and was embedded within this space. And you fully understand that you can orchestrate the access control So for example, as a visitor, I will see certain layers of certain application. As a technician, totally different set of application. As the owner, totally different set of application. So I can design which type of information is relevant to whom. Now, a subtle point, very important one. Once we have this capability to basically recreate the world in real time, based on the person, based on the intention, or in the state of mind, something is lost. Something that is critical is lost if we are not doing it correctly. The only important quality of objective reality, as we call it, it serves as communication platform. We share those tokens. This is why we develop language to describe those phenomena like water, table. We don't have a word to the distinct separation between the water and the table. We don't have a specific word for the corner of this specific sign. Okay? Because statistically, it's not so used. So everything that we can share intention in order to perform certain tasks probably will get a specific name. Okay, so we can direct the intention and share the intention. This is the most important aspect. Share the intention. It's very efficient to say, hey, please give me the water, and the person knows exactly what to do. Although we agreed that every object is infinite in its level of semantics. Because when I say water, my subjective stream of consciousness, my associations, my memories, totally different than yours. But we can collapse to the practical aspect of please hand me the water and sort of transcend all this infinite knowledge associated to this subjective knowledge associated with it and agreed on the simple pragmatic function. Now, let's say we want something more complex. Let's say we are arguing about the design of this chair. Now, just saying chair is not enough because we decided to go in depth. And maybe you are more classical, you are Louis XVI type of guy, so you see totally different this chair. Maybe you are a person who is building chairs, so you'll see the ergonomy, you'll see the structure, stability, and perform an action. Shareability is the most important concept in any created reality. By the way, the web becomes so successful just because shareability was preserved. Think about all the frictions a piece of content has from the server. You know that no document is reside as full in a computer on Google servers or Amazon servers. It's fully breaked into pieces in multiple servers all over the place. So once I fetch this document, all this information is aggregated, registered, transferred, reconstructed via my specific device, whether it's a mobile phone or a tablet, via my specific operating system, via my specific browser, in a very accurate manner. This is the great success of the web. This is the only reason why it succeeded, because content is pure. Once content is pure, I can tell you, hey, look at this website. And it has meaning. If it was altered via all these frictions through the hardware device, the operating system, the browser, then it's meaningless to say, look at this, because it will be changed. So I cannot actually direct you and create a shareable transaction. So the internet was orchestrated in a way, because it was based on the protocol, the CPIP, the handshake, and later on the HTTP and, of course, HTML. The protocols taking care that the content will come in one piece accurately. So once, let's say we have this amazing capability to basically be in the matrix, creating reality at will. Very convincing reality because sound already very convincing. Visual, I showed you, very convincing. So what remains is basically the haptics, the ability to feel the object or to smell the object, true. So those are also a very big fields of research under development, how to generate those haptics. And my friend now is using the neuroplasticity for people who are blind to see sounds. So the visual area now train itself how to differentiate between sounds that are reflected based on the visual perception or the visual scenery. For example, give this example, let's say a smile. Let's say somebody is smiling. So the system will generate for me the sound like this. So it already configure the visual perspective of what is there. I'm fully blind, but I map the visual field into sound field that has semantics that sort of giving me constantly the information. And once it's correct, I have the affirmation to strengthen this mapping between visual and sound. So I can do that for haptics as well. Yes? I can use multi-sensors to generate a feel of touch without actually touching. So once we have all this amazing ability to be in a matrix, basically, can we give this power to the AI of Google? Never, because they have different intentions than us. They want to get more money. They want more data. So if they, for example, their AI understand that when you see, for example, numbers and data, you are more inclined and more intrigued to create an interaction. So they can present you exactly the things that will evoke and train you, basically, the thing that will evoke an action that is beneficial for Google. They're already doing it, of course, okay? But now it's much more powerful because you don't have anything to compare where you are within this space. It's like because certain networks, they calm me down, but worrying a bit because some other signals are there. I see the fire, so some neurons say, fire, fire. But other neurons say, relax, guys. We know what we're doing. We're in a movie. You know that in the first movies, this wasn't the case. We are trained. But the first movie, there was one movie that there were train coming directly to the audience. They were standing, and it was a black and white movie of a train coming from a tunnel, I think, or something. And I think 30 or 50% of the people ran out of the cinema because they didn't have enough information, enough data to relax them. It was so overwhelming, so the brain didn't take the chance. Say, you know what? I don't know. Run away. I don't know what is going on. Okay? So once we are fully immersed in this type of reality, we don't have these other aspects of reality to sort of balance the immersiveness, the suggestion or convincement of this reality. For example, in mobile phone, even if there's something that is, let's say, very convincing, I still can do that and be in different reality. I can switch off very fast. It's a very important thing. Some of the research why VR or those VR devices didn't capture it still like in real mass is because of this, the switching. When you are a gamer, even gamers, because before they thought gamers will bite like crazy. But think of it. You're blocked on it. Okay? And you are trapped. Now, if you want to just refresh your brain for a second, it's such a big hustle. When you are playing in front of the TV set, Mom, sandwich! All right, I'm switched off, I'm switched on. I'm in control how much I want to immerse in the environment. Once this is here, I'm losing this control. Okay, so it's very burdening to the brain. It feels like heavy. So, yes. And don't forget, this information actually contained in reality. You are not inventing it. We are simply exposing it. For example, let's say there's a tree, beautiful tree. The tree knows how it looks from the inside. He knows once there will be winter, how it will look in the winter. So all this is there. The information is there. But we don't have interface. So look at the tree. In order to understand the name of the tree and some of its properties or qualities, I need to go to Google, to take pictures, to try and find out how to aggregate information to attach to this object. But if I can layer, let's say I love this, and I have this as a preferences. Every time I see a new piece of vegetation or tree, automatically I see and I can browse through different layers of data associated with that thing. It's amazing. It's like before search engine, if I wanted to do a research, library, friends, traveling sometime to other libraries because you don't have the books. Now it seems ridiculous. It seems ridiculous to invest so much effort just to get the information because now you're investing this information in analyzing it in a different way. So information is commodity, but analysis is proprietary. The way you analyze the information. So how you prevent this from being the power of Google or Apple or those hardware platforms? So I'll give one thumb rule, very important one. The power, the more the power is bigger, you need to distribute it. Spending, let's say, 5 hours in the internet, actually more. But we are lying to ourselves, it's 5. Let's keep this. Okay? So if it belonged to somebody, it's crazy. Controlling the world. So the web has to be decentralized and distributed. And you see that we have so many publishers. Of course, it's not a unified graph. It's exponential decay. There are big parties and they have smaller, but it's distributed. Nobody owns the internet. So nobody can own the world or the digital world. So you have to distribute correctly the digital publishing right. Who can publish information cross-platform, cross-device? So whether you have Google Glass and I Apple Glass, when I'm here, we are seeing the same thing. Because the one who actually create this digital space is the owner of this room at this moment. So if you look outside, everything in reality, there's a publishing right to somebody. I cannot change anything, any pixel of reality, there's someone that is the owner of the rights to publish. This building, this tree, I cannot do anything. Because society structured it in a way that it will be accountable, that there will be a single authority or a clear path of control. This is why graffiti painters, they have to sneak out in night and do something that is considered to be illegal because it's not theirs. But there is someone that is allowed to paint there if he's going through the right pipes. Same goes with the digital publishing now embedded in space. Let's start with publishing right of the physical space. And he gets the right to manage his digital ecosystem. So he's now a digital publisher. And he should be, because he's hosting us. I came here to be hosted in this space. He needs to know better than anyone how to leverage this physical space with digital capabilities so I'll have a better time spent here. So this is what we have constructed in our operating system. Ability to distribute and give all the operators and the owners of the real estate the ability to enhance their physical real estate and transform it into a digital real estate. And by which you maintain the concept of shareability. Why? Because now you and I, doesn't matter what is the platform we are seeing, wearing, we're experiencing the same digital application because they are designed by the owner and they are in space, not in Google. Okay? They are part of the space. You understand the difference and why it's so important? Nobody addresses this. The reason I'm doing what I'm doing is exactly because of that. To preserve the concept of shareability, to preserve the concept of accountability in a world that you can do everything you want. It's like giving everybody a freedom to be God, but still we need to manage our relation. By the way, this is exactly the thing. All of us is gods. We are the only one who perceive the world as we perceive it. The only one. Across time, across space, across experiences, memories, everything you have in your reality, it's your brain constructed. Each and one of you is actually a God. And when you will tap your infinite potential of mind, you'll fully recognize it. And then we'll also understand we are simply one God. So right now we're learning to discover it. So we're still not aware of this oneness, of this full creativity. But if you know a bit of quantum physics, you know this is what quantum physicists discovered. Because they wanted to know what is the absolute truth. This is what physicists are trying to do. What is absolute? What is not relative to a perspective of an observer? What laws governing the states of the physical system that are not dependent via the type of observation? So they say table, but table, we already agreed, it's dependent. What is a table? So now I break it up to its molecules, and then to its atoms, and then we go further, and then we reach quantum fields that are probability fields with superposition of endless states within them simultaneously, and only when we interact with them, it collapses into a single observable. So when they tried to reach deep into reality, they came back to consciousness, to observation, to measurement. The very famous argument between Einstein and Niels Bohr was exactly this. It was of the nature of reality itself, whether it's material and objective or fully interwoven, entangled with consciousness and observation. They were very good friends, but Einstein refused to accept the fact that objectivity and subjectivity are fully interwoven into each other. That things are not things that have a predefined state in each given moment. So there's a story that they were walking, I think it was Copenhagen conference, one of the most famous fundamental conferences of all the smartest people around physics at that time to understand and to decide quantum physics formalism. And they were walking nighttime on the street, arguing. And then Einstein told Niels Bohr, what do you want to tell me? If I'm not looking on the moon, it does not exist? And this is not two people on marijuana. These two Nobel laureates that changed physics forever, arguing. And Niels thought a bit and say, yes, Herr Einstein, this is what quantum physics teaches us. It's difficult maybe for you to accept, but this is what it teaches us. So reality already, in its fundamental aspect, is potentiality, is pure potentiality, before it manifested out. And it's also encapsulated in a beautiful saying by Rodin. Augustus Rodin is a very famous sculptor. He said, in a piece of stone, all statues existing already. So the piece of stone contains all the potential of every statue that can be ever presented or crafted. So basically the artist, what he's doing, is limiting, collapsing the infinite potential into an observable. He's doing exactly the measurement problem that we have discussed. This is what we're doing in our consciousness constantly. Constantly. Because right now, you are everything from potential field, pure potential. Without space, without time, without any type of observable that collapsed into a phenomenon or measurable phenomenon. You are this. And moment by moment, you are convinced that there is a partial, limited reality. And the thing that does the trick for you is your thoughts. Once you have a thought and you are attached to it, it creates the world then and there for you. And the only reason why you think the world is stable and it's going through time in a similar way, so I'm me that I was like 2 seconds ago, is because this current thought connects all the similar thoughts and enhances them into a solid, oh yeah, it was like this before. But if I'm very true to myself, I'm totally different than the person I was 2 seconds before. I had a different emotion, different thought. I observed on different phenomena. I was thinking about totally different things. What is the connection? So everything you see as technology is nothing but reflecting on already existing potential within reality. We're just sculpturing it in a certain manner to get a specific statue. And I'll allow myself to use the Old Testimony for a second. And you know that in the Old Testimony, the most important thing is the Ten Commandments. Okay, that was given by God to Moses, was presented to Hebrew people, when they were celebrating the gold calf or something. Moses was terrified. Break it up, go again, get another piece of knowledge. And this is how we got the 10 commandments. Now, the first commandment is, I'm God, don't do any sculpture or any image. And I want you now to think of it in the context of the conversation we had. I'm God is mean, you are God. Because the name of God, when he says, is simply presence. So I'm always here because I'm your presence. You don't need to look at me. I'm the mere presence is me. Don't do any sculpture or any image. What it means? Your mind is not your mind. Mind is generating images constantly, and sculpture is curving this piece of stone constantly, and you see this golden calf. For example, my name is this. My profession is this. I did this. I'm not good. I'm good. I'm beautiful. I'm ugly. These are all sculptures that our mind gives us. Once we believed in them, we're a slave of them, and we're creating a world in the shape and form of this specific sculpture because it defined already the context of the world that is going to be created. I'm conditioned by it. But once I'm remembering that presence is God, and not all these suggestions of mental perception that are transient and constantly changing, this is what is the first commandment. So it's nothing but pure meditation to put you back into the state of pure consciousness, as opposed to keep jumping with each thought, with each emotion you have. And only when you have this center of stability, of knowing who you are, you can enjoy the movie. Thank you very much, guys.
Distinguished authorities, with honor us with the Beresens Polytechnic community. Ladies and gentlemen, my name is Mauricio Martín Gascón, a Networking Assistant Director of the Centro de Investigación en Computación, and with a kind regards from Dr. Francisco Irán Calvo Castro, who Acting Director of the Centro de Investigación en Computación, who for extraordinary reasons apologizes for not being able to attend this event. We are proud of being able to welcome to this center, and in addition of thanking the presenter, Dr. Emil Alon. Thanks so much for his extraordinary participation in such an important conference and for everyone's interaction, presentially and virtually. An activity that well ardently generate new ideas and even projects among students, teachers, and of course at the institutional level to continue generating ideas to provide feedback on what has been exposed here. Once again, I appraise the participation of all of those present here, and I invite you to remain aware of the activities that are carried out by the IPN to continue putting together La Técnica al Servicio de la Patria. Thank you so much. It's an honor, and thank you so much for the presence.
I welcome each and one of you to approach, whether with ideas of how to leverage, how to elaborate via applications, via technologies, and go with this process of decentralize these capabilities while enhancing reality with all these what we have discussed or any other aspects that were intriguing for you in this conversation. Okay, so you are more than welcome. Thank you.
Thank you so much, Doctor. Thank you for all and have a nice afternoon. Thanks so much.